Hello and welcome to our physical science lesson on the topic of sound. Let's start with sound terminology. Compression, a region in a sound wave where particles are closer together than average, creating high pressure. Rarefaction, a region in a sound wave where particles are farther apart than average, creating low pressure. Pitch, the perception of sound frequency. Higher frequency sounds are perceived as having a higher pitch. Loudness, the perception of sound amplitude. Higher amplitude sounds are perceived as being louder. Doppler effect, the change in the perceived frequency of a wave due to the relative motion between the source and the observer. E.g., ambulance siren. Understanding sound, sound is everywhere in our daily lives. From the music we listen to conversations we have, to the roar of traffic. But what exactly is sound, and how does it work? 1. The nature of sound. Sound is a longitudinal wave caused by vibrations. When an object vibrates, it creates pressure variations, compressions and rarefactions in the surrounding medium, e.g., air, water. These pressure variations travel outwards as sound waves. Unlike light, sound cannot travel through a vacuum because it requires a medium to transfer the vibrations. 2. Properties of sound waves. Wavelength, lambda, the distance between two consecutive compressions of high-pressure zones in a sound wave, measured in meters m. Frequency, f, the number of compression cycles that pass a point in 1 second, measured in hertz Hz. A higher frequency corresponds to a higher pitched sound. Amplitude, the maximum change in pressure compared to the average pressure. A larger amplitude corresponds to a louder sound. 3. How we perceive sound. The human ear perceives sound based on its frequency. An amplitude, pitch, determined by the frequency of the sound wave. Higher frequency sounds are perceived as having a higher pitch, e.g., treble notes versus bass notes. Loudness, determined by the amplitude of the sound wave. Higher amplitude sounds are perceived as louder. 4. Sound and the Doppler effect. The Doppler effect explains the change in perceived frequency of a wave due to the relative motion between the source and the observer. Imagine an ambulance siren. As the ambulance approaches, the sound waves are compressed, leading to a higher perceived frequency, higher pitch. As it moves away, the waves are stretched, resulting in a lower perceived frequency, lower pitch. 5. Applications of sound. Sound waves have numerous applications in various fields. Medicine. Ultrasounds use sound waves to create images of internal organs. Navigation, sonars use sound waves to locate objects underwater. Security, ultrasonic sensors are used in burglar alarms. Remember, sound speed depends on the medium it travels through. Generally, sound travels fastest through solids, then liquids, and slowest through gases. Reflection of sound waves is used in applications like echolocation bats and sonograms. Thank you for listening. Kindly attempt the following assessments to deepen your understanding. Let's meet on our next class. Bye-bye for now.